Okay, guys, hi everybody. Today we are working on solving equations and problem solving, and this is Algebra 1 first video. So we will be working on solving equations, but first we have to understand all the terms and the vocabulary words, everything. So what is a term? Term is a number or the product of a number in variables raised to powers. So what is term? Term is a number. A term could be a number. For example, 7, that's a term. I'll write down here, that's term. So 7 is a term. The product of number, like a number and variable. So product of number and variable means like I have a number 5 and I have a variable x. So that's they are multiplying. So that's a product. So product of variable and a number is also called a term. And also, for example, in variables, if I have just variables raised to the power of something, this is also a term. If I have 4x y squared, this is also a term. You have variables and you have a 4 multiplying with each other raised to the power y raised to the power 2. They're all, this whole thing is called a term. So let's figure it out, numerical coefficient. So I'm gonna figure it out which ones are numerical coefficient. Now this is 7 is a numerical coefficient. Coefficient is a term of a term is the numerical factor, like a number, numerical term, that's a coefficient. So what is the coefficient here in this term? It's 5 because that's what the coefficient is. That's a number. What is the coefficient here? Because I don't see any. I cannot see, but there is invisible 1, so it's 1. What is the coefficient here? That's 4. So I just wanted to review this whole thing really quickly with you. Now, I have a question right there. Identify the numerical coefficient in each term. The numerical coefficient for this one is -6 because we have to keep the sign. This one coefficient is 55. The coefficient of that is -1 because we don't see it, but there is an invisible 1. Okay, now what is like terms? I want to do that too, like terms. So I'm going to write it down here, like terms. This is really important, guys, like terms. Like terms contain same variables. When the term has same variables raised to the same powers. Okay, so and all numbers are actually like terms, like all these numbers 7, 5, 6, 7, 8, 9, 10, all of them, they are all like terms. Okay, so let's do some examples for the like terms. If I have example number 5x and 4x squared, so determine whether the terms are alike or unlike. If you guys pay attention, I have the same variables, but I don't have the same exponents because there is invisible 1 exponent. So the exponents are not the same. And we specifically said raised to the power, raised to the same powers. Same power, same variables. So no, this is unlike. They are unlike terms. Another example. If I have 8x squared y cube minus 14x squared y cube, and I have, that's not minus, I mean there is minus but it's a comma, and then I have comma x squared y cube. Now which ones are like terms? Now I'm gonna I can see each term, like this is 1 2 3 terms. I can see x are like terms because x squared x squared x squared. But if you check the y cube, y cube, y cube, oh, they are like terms. All of them are like terms. There is invisible 1 coefficient, but they are like terms. So they are all like terms. Okay. Now, let's see what else we can find. I'm gonna do some questions here, combining like terms. Let's use eraser so I can clean up this. Okay, remember the like terms and remember all the coefficients, and like terms means, and the terms in the like terms were same number, same variables, and same exponents means they are all like terms. Okay, perfect. Now let's go back there. Now simplify each expression. Okay, the first one is 5x minus 2x. Another one I have, I'm just going to write 12x squared plus 2x squared. Okay, so if I'm simplifying this, are these like terms? Before I do anything else, are they like terms? Yes, same variables and same exponents. Yeah, so 5 subtract 2 will give me 3. X is going to stay as x. So yeah, true. These are also like terms because same exponents, same variables. So 12 plus 2 will give me 14x squared. So that's my thing. Okay, what else we need? If I have, for example, I have another example, C, 2x plus y, and one more, I have -4, 3a minus 3b minus 10c. Okay, how do I solve this? Now, before I combine like terms, excuse me, before I combine like terms, you know that I have to get rid of this parentheses, and the only thing to clear the parentheses, we use distributive property. So if this is addition, that's also plus distribute. Positive 2 times positive x will give me positive 2x. Positive 2 times, this is times, okay, this times, time parentheses times positive y will give me positive 2y. Are these two like terms? No, we can't solve them. This is my answer. Next, again, parentheses has to go. So how do I clear the parentheses? Distributive property. So I'm gonna go here, this, that was a bad idea. There you go. Okay, let's go back. This, -4 times positive 3a is gonna give me -12a. You know, in my head, I always multiply signs first. So negative times positive is negative, 4 times 3a is 12a. Now let's go back to the second one there. Again, negative times negative is gonna give me positive, 4 times 3 is 12, b is gonna stay. Third one, negative times negative is positive, 4 times 10 is 40c. Do I have like terms there? Not at all, because all the variables are different. So now I don't have any variables there. Okay, let's do one more example. That would be D, which is going to be -5 3x plus 2 close minus 4x plus 1. Now again, get rid of the parentheses first. If I'm getting rid of the parentheses, then you know I have to do the distributive property. So multiply these two. Negative times positive is negative. 5 times 3 is 15x. Negative 5 times positive 2, which means negative times positive is negative, 5 times 2 is 10. Let's go back here. This is minus sign, and I can imagine a 1 here you can multiply. That's positive. So this is going to go here. This is going to go here. So -1 times positive 4x will give me -4x. And I'm still keep multiplying these negative signs, all the signs in my head. Negative times positive is negative, 1 times 4x is 4x. Negative times negative is, negative times positive is negative, 1 times 1 is 1. So the parentheses disappeared. Now do I have like terms? Yes, this time I have like terms. I have this and I have these two like terms. Let's deal with them first. Negative 15 and negative 4, which means different sign, keep the same signs we keep, we add. So that would be negative 19x. Then I also have another like term, this and that one. Negative 10, negative 1, I told you all the numbers are like terms anyway. Negative 10, negative 1 is going to give me negative 11. So do I have any like terms here? No, that's my answer. Okay, now we need some algebraic expressions, which word phrases as algebraic. You guys have to take a picture of this and keep it, write it down in your notebook. These are all the vocabulary words you're going to need solving word problems. So let's go and solve these two. Write the following phrases as algebraic expressions. Simplify if possible. Let x represent the unknown number. A, 5 decreased by a number. What is decreased by means? It means subtraction, and you can tell right there. You see that this is decreased by. So how do I translate this? 5 is gonna go as a 5 decreased by a number like x. So this is exactly how it goes. You know, operation goes in the middle between, not between the two terms, between two terms, whatever we have here, that's operation. If I try this, look, quotient of a number in 12, and you know the operation like addition, subtraction, multiplication, division goes between the two terms, so I have to automatically move that there. So I can say x divided by 12. Now you have to be very careful in division, because whatever they say first, like they said number first and then 12 comes later, number and 12, so that number is going to be first. Like this number is going to be a numerator and 12 is going to be a denominator, that's for sure. Okay, so the quotient goes in order. If the question was, like for example, the quotient of a 12 and a number, if this was the other way around, like a quotient, so I can say 12 divide a. For the number I use just a, like you can use an x right there. You see that? So it's exactly supposed to go in the same order. So I can also write this like that. Okay, so this one goes like this, and since the number was first, so it's gonna go like that. Okay guys, please comment below if you have any questions, and I will keep making these videos and see if it would help. Any questions, comment below. Like my video please if you like it, if it helped you, and subscribe. Thank you. Have a good day. Bye.